Hello everyone. In this video lecture, we are going to find a simplified Boolean expression in the form of product of sum. Now here, we are going to solve two problems based on this topic. So let us start the class. Now this is the first question. Function of x, y, z is equal to sum of minterms are 2, 3, 6, 7. Now coming to this function, this is the three variable function and the minterms possible by using these three variables are listed in this table. They are from M0 to M7 and whatever the minterms present in this function, for those minterms we are assigning 1 in that respective places, and whatever the minterms are not present in this function like M0, M1, M4, M5, for those minterms we need to assign zeros. So to find a product of sum expression, we need to use a three variable karnaugh map because this is the three variable function. So we are going to use three variable karnaugh map. So this is the three variable karnaugh map. In this x variable we are considering to the row side and yz variables we are considering to the column side. So when we are finding a product of sum expression, we need to consider whatever the minterms not present in the function. So here whatever the minterms not present in this function, they are M0, M1, M4, M5 and we are assigning zeros in that respective places. So to find out product of sum expression, we need to group the zeros in this karnaugh map. So here the number of zeros are here in M0 place, M1, M4, M5 place means we are making a group like quad here. So for this group, if you want to write a prime implicant, it can be written like this. X will be changing variable, Z is also changing variable. So the prime implicant will be equal to Y complement. So this is the karnaugh map which is going to provide F complement which is equal to Y bar. Now here in this karnaugh map, these are the points we need to observe that here the ones marked in the map represent all the minterms present in the function. The zeros marked in the map represent the minterms not included in the function. So therefore denotes the complement of the function. So when we are combining the number of zeros, adjacent zeros, it is going to give a prime implicant. With that prime implicant, we are going to find the function which is equal to F complement. So here we are able to form only one group which is equal to Y complement means the function F complement will be equal to Y complement. But here we need to find a product of sum expression. For that one we need to use to obtain the simplified function in product of sum, we need to apply De Morgan's theorem. So after that finding F complement, for that function we need to apply De Morgan's theorem. Now we will consider the De Morgan's theorem. Now here the De Morgan's theorem to apply to any function, here we need to consider 2 points like we need to take the dual and complementing each literal in the function. Now I will explain this point by considering one example like a function f complement which is equal to x in y plus y complement. Now we will apply De Morgan's theorem to this function. Nothing but firstly we need to consider dual of this function and after that we need to find the complement of each literal. So finding dual of this function, here we are going to interchange AND operator with the OR operator and OR operator with the AND operator. Nothing but here we are replacing dot with plus and plus with dot. So here we have x and y. So we replaced this dot with plus and we have plus here. So we replaced with dot. So this is the procedure we need to follow when we are finding dual. So after that we need to find complement of each literal. So here we have normal variables x, y. So here we replace it with x complement, y with y complement. Here we have y complement. So we replace it with y. Nothing but this is the procedure we are going to follow to apply a De Morgan's theorem to any function. Now here we already find the f complement which is equal to y bar. So for this function we need to apply De Morgan's theorem. So here after applying De Morgan's theorem here, we can find like f will be equal to y, because in f complement function there is no like a product term or a sum term. Only one literal we have, that is y complement. So after finding dual also we can have only y complement. Next, after finding dual we need to apply complement each literal. So we have y complement means we are going to have only a variable y. So function f will be equal to y, which is the POS, that is product of sum form for this first given Boolean function. Now we will simplify the second Boolean function, which is equal to function of w, x, y, z is equal to sum of minterms are 0, 2, 5, 6, 7, 8 and 10. Now to find out product of sum expression, here we need to consider a 4 variable karnaugh map, because this is the function with 4 variables. So here we considered a 4 variable karnaugh map where with w, x variables are common to row side, y, z variables are common to column side. Now here we are arranging whatever the minterms present in this function. For those minterms we are assigning 1 in that respective places. And to find out product of sum expression, mainly we need to consider whatever the minterms not present in that function. For all those minterms we need to assign zeros. So here M1 is not present, so we are assigning 0 in that cell. M3 is not present, so we are assigning zeros in that cell. So similarly, whatever the all the minterms not present in this function, we need to assign zeros like this. Now after this, we need to combine the adjacent zeros here. So by that one, we can make a groups. So here this M1, M3, M9 and M10 minterms having zeros here. So by considering these 4 zeros, we are making a group. And similarly here M12, M13, M14, M15, by these 4 zeros, again we can make another group. And we left with one more zero here. To cover this one, here we need to consider M4, M12 as a group. Now after grouping, we need to write the prime implicant for each group. Now here for this group, we can write here W variable is changing, X bar will be common. So here X bar, and Y variable is changing, Z variable is common. So for these 4 zeros, the prime implicant will be X bar and Z. Now here for this group, the prime implicant can be W and X. Now here for these 2 zeros as a group, the prime implicant can be X is common, Y bar, Z bar is also common. Now here by grouping the number of adjacent zeros, we are going to find a function like f complement, which is equal to X and Y bar and Z bar plus X bar and Z plus W and X. Now for this function f complement, we need to apply De Morgan's theorem to find out product of sum form. So here to apply De Morgan's theorem, firstly we need to find dual, and after that we need to complement each literal in the dual function. So here dual applying to this function, here we can replace the dot operator with plus and plus operator with dot. So by following that procedure, we can find out the dual of f complement like this. Now for this function, we need to complement each literal in this function. So we can observe that here x means we are having x bar, here y bar means we are having y, here z bar means z. Similarly, here w means w bar, here x means x bar. So this is the final product of sum expression for the second Boolean function. So now by following this procedure, we are able to find easily the product of sum form to any Boolean function. Thank you for watching this video.